Thanks. Welcome, everybody. It's good to see you all here at the very tail end of the conference. I appreciate you coming in here to keep a good seat for James Dempsey. I will try to keep you entertained before then. I'm feeling quite unworthy. But today, I'm here to talk about rethinking syncing. So let's talk about what do I mean by syncing, first off. And in the context of this presentation, because syncing can have lots of different meanings, right? What I'm talking about is, let's say you've built your wonderful app, right? So it supports all these different screen sizes on the right, and it talks to data in a server, and so you've got some data on the server, and you want to get that to your app, and you got some data that you've created in your app, and you want to get that on the server, right? So that's what I mean by syncing in this context. And for the purposes of this discussion, I'm going to look at it in two different perspectives. Number one, we're going to talk about when you've got data on the server and you want to get it onto your phone, and that's kind of like the biggest use case that a lot of apps use, right? Is you just pull down the data and display it, and that can be images or audio or text or news or whatever, right? And then it's helpful to think about user-created data that, you know, our mobile devices are really powerful, right? So we can take pictures, we can type stuff in, we can record audio, we can get sensor readings. There's all kinds of cool stuff we can do with these devices these days. And a lot of times we like to sync it up to a server so we've got it all in one place, right? Or we can use that data for other purposes for our apps. So there's a number of different things that you have to think about when you're syncing data, right? Like how much data do you have to get back and forth? I should stand back here so I can see my notes. When does the user want to see or use that data? How much or how often is that data changing? And then do you need to be offline? And I think the answer to that question is always yes, or should be yes, in all but a few rare cases. Because when you do an app offline first, you get a really good user experience, right? It saves a lot of issues when you're trying to upload data or upload user-created data. It gives the user a much better experience. And then when you have the data locally and you can access it while you're trying to do stuff in the background, you can do a little bit of magic and make your app seem like it's a lot faster than it really is. So I would always say you should start with offline first and then back up from there if you can't do it. So, all right, let's talk about the current state of the art, or the current way that we typically sync data from a server to an app and vice versa. So who all has done stuff with REST APIs in their apps in this room? So quite a few people. Who all's done like another way of doing that? So not using REST or not calling an API. Cool, so a few people in the room, cool. All right, so what I'm gonna do is talk about the way that I've seen this implemented in a number of apps. I've built syncing solutions for a number of different apps, and it was all painful in different ways. So I'm gonna describe some of that pain, and then we'll talk about, you know, kind of a new approach. So the typical REST approach is, you know, you've got you know, a resource like maybe on my green bars, right, in my data that I've represented there. And I can get a list of them if I talk to the green URL ending point there, or endpoint. And then if I want to talk to specific resources, I might have an identifier in my URL, and then I can add and update data, and then I can delete data using a REST call. Now, REST isn't always the most efficient way to do things, because you might just want to try to do a lot of stuff with one call. So you may not want to use the REST approach, right? You might just want to pile a bunch of stuff into a call. So there's a bunch of different approaches to this. All right, so I'm going to talk about some typical approaches that I've seen with REST or not REST or whatever, right? There's the everything approach, which is I just make a call and I pull down everything that I need every time, right? And that's just the server isn't very sophisticated, and I do a bunch of work on the device when I get my data down, right? And then I sort that out, and every time I need data, I just pull everything, right? I just delete what I have and pull down what I need. So that's one approach, not very efficient, uses a lot of bandwidth, kind of painful, right? Then there's a net change approach. We're going to talk about that in a little bit more detail, and that's sort of, you know, you got a known starting point, and then you just pull down what you need as it changes. We'll talk about that in a little more detail. Then there's the kind of, sort of, but not really net change approach, which is your server is sophisticated enough to give you part of net change, but not all of net change. And I'll give you an example. I was working on a client recently where they had no problem identifying adds and changes, but they couldn't tell me deletes, right? And this was just the server setup wasn't sophisticated enough to do that. So the answer was, well, we'll do our net change call to get the adds and delete, or the adds and changes, and then for the deletes, I want you to make a call, and you're going to get a list of all the IDs in the database, and you figure it out. So, yay, right? Perfect use of mobile computing resources, right? Then there's the sort of as-needed approach, and this is really more of like the web approach, right? Where you go look at a list and you get sort of a paged, sort of the first group of what you need, and then you get more and you get the next page, and you tap on something and you go fetch the detail. And that's really sort of how the web works, and it works very well, right? But in mobile, that may not always be the best thing for your users. All right, so let's go talk about the net change approach in a bit more detail. So the way this is typically done is you've got an endpoint for all the data that you need, and you typically pass it a date or something like that, or a timestamp that says, all right, I have some data on my device, my red and my green dots there, but I want to know what's changed since this last date. And then the server will figure out, oh, there's a green and a blue dot that you need, and it'll send those over when I make that call. So this approach typically will update from a known point in time, and it might be that you've never done it, so you have to fetch everything first, and then update your known point in time, and then fetch from there. This is typically a more efficient implementation, so it's a good way to minimize the amount of bandwidth that you need, but it requires a bit more complex logic on both sides, right? The server has to be able to know when data has been added, when it's been changed, when it's been deleted, so you don't have a terrible process there. And then it requires one source of truth for that since parameter, right? Because I'll tell you from personal experience, not having one source of truth for that gives you some very, very subtle and very annoying bugs that are hard to figure out. So you always want that coming from one place, so that way you're always in sync. All right, so the process for this is typically, you make your API call, and that gets your list of your data. So in this case, my red, green, and blue objects, and it tells you what actions have happened to those. So then when you get that list of the actions and the data, then you iterate over those lists in your app, and then you process them and store them in your local storage, right? So you make your adds and your changes and deletes so that it matches up with what's on the server. And then once all that's done, you can say, okay, UI, I've got my changes, please go update. So let's talk about that in a little bit of detail and see how you would do this in code, right? So this is just going to be a very general example that I sort of hacked together. And this might be familiar, might not be, but this is kind of the way I've seen it done in a lot of places. So the first thing you need to do is prepare your API call. So I've got some stuff up there where I'm like, I've got a URL request function that'll spit back a URL request, and I give it some parameters that I'd like to do, and so that's just a simple dictionary of parameter name, parameter value. And then I'm gonna have that grab my base URL, use URL query items, and build a nice string. And so this way I'm not doing any of my URL encoding or any of that. I let the foundation stuff handle that for me. So I'll go through my query items, I'll add those to my URL request, and then I'll just return a URL request with my URL. So that's pretty simple, but it's a little bit of code, right? All right, and then I'm gonna make an API call. And in this example, I did a generic approach to this. My daughters have just come in the room, so look back and say hello. So in this case, I've got a generic approach to this. A lot of the code that I've seen has not been generic, right? Like a lot of times you'll have to process each call a little bit differently, right? So you can't necessarily do it in a generic way. But this is just kind of a good abstract example of, this is the stuff you need to do every time you make a call. And the couple of things that I would like to point out here are that the first one is, anytime you make a call, you need to check your error conditions. So the first one up there is I'm checking the error in my URL session task response, right? That tells me, well, did I have a network connection or not? So I need to handle that. Then I need to check my response. And if I actually did get a response, I need to make sure it's a 200 OK, right? So I actually got what I expected, and then I got the data in the response that I expected as well. Because I could have gotten a 500 error, that says the server blew up, or 404, I'm calling the wrong thing, and I might not have the data that I expect, right? So I need to handle that condition as well. And you need to handle that on every single call that you make, right? So you need to handle both of those situations. So none of that's particularly complicated, it's just you need to do it every time, right? All right. So next up, I've made my call, I got some data back, that's all good. I need to ingest that data into my local storage so that I can do some stuff with it, right? Or I just need to ingest it into a usable format that I can pass around in my application. So in that case, I might presume that I'm getting some JSON back. I'll go ingest my JSON, and then I've got a t.ingest here method. That might be whatever my data type is, I can ingest it this way. If I'm doing core data ingestion, it might be a little more complex, right? I might have to, make sure that I'm talking to the right, oh gosh, I haven't done core data in long enough. I'm gonna forget how to do it. But yeah, you might have to do some more complex ingestion depending on what your local storage is, right? All right, so you do all that, and now let's have a look. You've got a lot of code up there, right? And let's say, in this example, you really did have to make separate types of calls for every entity that you have. And in this example, it's a really, really simple app, right? I've only got 3 data types, my red, green, and blue. But what if you have 20, right? I mean, this adds up to a lot of code, right? So a lot of networking data ingestion, just pulling data down, can really add up to a lot of stuff. Even if you do it efficiently, it can still be quite a bit of code. So now we've really only talked about the 1/2 of data syncing, right? So we've talked about pulling the data down from the server and getting it on our device. And I didn't even show you, all the stuff that you need to do to throw it up on the screen, right? So that's just half of what we need to do. Now, let's talk about how we get the user-created data up. I'm not going to go through all the code because, I'd like you all to stay awake. So there's a couple of different approaches to getting the user-created data from the device, right? The first one's really just the online only. So you're just not going to attempt to deal with any situations where you're offline. And that's the case where I type in some data and I hit save or send, and then it spins for a second, and then it comes back and it says, sorry, I didn't work, or yay, your new data has been added, right? And if it fails, you're out of luck. You can either try it again or just give up, right? So those are typical implementations when you just do the online only approach, right? So you just hope your network works, and if it doesn't, user's out of luck. Now there's the persist the network call approach, which is, okay, it failed in that case. I'm going to save that, and I'm going to listen to the network and see if I get a better condition, and then try it again. Now the complication with that is, right, that might be 10 minutes later, an hour later, that might be backgrounded, and if it fails again, or if there's some other problem that comes up, how do I let the user know, right? So there's that approach. Then there's the offline first queue approach, and I've built this a few times as well. And that's really where when you type in the data, or the user types in their new data and they hit save, it gets saved locally and then queued, and then you have a job running that says, okay, I'm going to keep trying to send my data up, right? And when it does, it'll update your local data and say, yay, saved it. And then you can have some UI stuff that says what the state of that data is, or it can show that it's in sync or syncing or any of that kind of stuff too. But you need to handle all of that as well, right? And that can actually get quite complicated as we talk about some complications to the REST syncing, right? So when you're in offline mode, queuing those uploads can really be kind of a hassle, right? Because you need to make sure that the queue processes in the right order if you have dependencies. You need to make sure that the queue restarts properly and knows the state of stuff that's gone up. So for example, if something has failed in the middle, like you lose your network connection in the middle of an upload, well, do you know if it actually saved correctly on the server or not? Maybe you didn't get your response back. Who knows? Maybe you're adding something twice. You need to handle all those types of situations, right? And then with dependencies, there's a whole bunch of different issues potentially there. This can happen in both the downstream and then the upstream approach as well. So you might need to fetch one entity before fetching another, right? So I might need to fetch a customer before I know what orders are associated with that customer, right? If the customer fetch fails, I can't fetch the orders. I might need to create one entity before I create another. Like if I'm on Instagram, for example, I might need to create a post before I can make a comment against it or do a like against it, that sort of thing. And so you need to be able to handle all those if you're doing offline or any other approach, right? And then last but not least, there's sort of the model changes. Like over time, you're going to add new features to your apps, right? And then there's going to be cases where the sync API changes with releases. You got to match that up when you make your release. You need to make sure that the API is ready for your new call, right? And it can handle the data that you're going to send it. And then you got to make sure that you're still supporting your old versions, right? So you're not breaking the existing app when you put up a new API. And last but not least, yeah, you got to support those older versions, right? So you just don't want to break those when you change your API. All right, well, I'm officially out of breath, and Captain Kirk here is going to say, yeah, there's got to be a bar, right? Anybody need a drink after doing all that? A lot of work. So all this, you know, after doing this for many years, started making me think, what if we didn't need to write all that syncing code anymore? What if there was a way to not do that? And since I'm a lazy bum sometimes, I gave this some thought. So there are what I will call a class of databases that are eventually consistent. A lot of them are, you know, like a server-side database, right? And a lot of them are NoSQLs. So they're not a SQL-based database, but they'll be like, you know, a key value kind of store database. A lot of them have a sync server or a syncing type support. And then a lot of them have a mobile database component as well. So there are a number of different solutions out here today, and they'll call themselves by different marketing names, right? So some of them call themselves like a real-time database or, you know, an always-on database or something like that. I like to call them eventually consistent because you can have an offline state and then you can call up when you get a connection and then it'll sync up and then it'll let you know when it's consistent, right? So that's the way I like to think about it. Let me give you a couple examples of these database solutions that are out there currently. The example that we're going to talk about today is from Couchbase. This came from the CouchDB, which I believe was an open source project, and Couchbase has sort of built their own product on top of that and sort of gone beyond it. So we're going to talk about that solution in particular because I've used that to build an app with. Realm is actually quite similar to Couchbase in this regard. And then Google, Firebase, AWS AppSync, and then IBM Cloudant. IBM Cloudant actually is based on Couch as well, so it's kind of a similar thing. And then Google, Firebase, and AWS AppSync each offer similar solutions, but they're not quite the same. They don't treat syncs the same way. And I've done a little bit of experimenting with both of those, but I haven't built an app with them yet. So today's example, we'll just go through Couchbase, and I'll just sort of show you the concept of how we can do syncing with something like this. And then some of the code that it takes to get that done. So let's look at the idea here. And the idea is, this is just the architecture of how the whole thing will work. I'm going to walk through some of these pieces here. So on the far left, we've got a Couchbase server. So that's a database. And you might have some services talking to legacy databases that can populate that Couchbase server. Or you can just put data directly into the Couchbase server from, you know, any other application that you build, right? But in my case, or the application that I worked on, we took some data from legacy databases and fed it into a Couchbase server in the format that we wanted. So basically, we just have a bunch of records in there that are formatted JSON that are exactly what we need in the app, okay? Then Couchbase has a sync server. And this concept, I believe, also exists with Realm. But if you're talking about like Google or AWS, it's sort of a different thing. You just really have a listener, and there's not really a server component necessarily. But the sync server's job is to make sure that anything that changes on the server side is reflected to the users that expect it on the mobile side, and vice versa. And that's all it does, and it does it very well. Oh, darn it. A little bit too fast. And then down here on the app side, there's a Couchbase Lite, which is the mobile database offering. And then your application will actually just talk to that. So as if it were core data or some other local data storage, you just talk to that data storage locally, and you're not even aware of the rest of the stack. So let's do a quick demo and just kind of see how this looks. So I built this simple app. And it's got some green bars, some red bars, and some blue bars. And I'm just going to be able to add and delete these different color bars. And these can just represent whatever data, right? So if you just imagine this could be any type of data you've got in a list, just some different types of records, for example. So as you can see, I can add some bars here. I'm adding some blue bars. And I can scroll around. And then I can delete some stuff, and it goes away, right? Super simple app. All right. So what's going on there? Like, what data do I have when I'm doing that? So right now, this is the app the sample app that I wrote. And then on the left side, that's the sync server. So that's actually how all this data is represented in the application. And if you'll notice on the left, there's a list of records. And there's a bunch of UDIDs over there. And each of those is just sort of a unique identifier for a record in the database, or that the sync server can see, right? And you'll notice there's 10 of those records, and I've got 10 bars in my app right now. Now I've selected one of those records, and you can see up there, there's some JSON, right? And so that's my data. And so each of those identifiers points to some data, right? And that's just JSON. So that's all that's going on there, is that that sync server just has a list of this stuff, and then my app can see it. Now with Couchbase, there's a term called channels, so that I can specify like what belongs to a certain user or a certain group of users or any other sort of way that I want to organize that data. And then that way the app can say, I'd like to subscribe to this channel and then pull the data that's relevant to me. And then the sync server is really smart about doing all that stuff for you. So that's what's going on in the app. Now let's take a look at what happens when I add some data. So right now I'm looking at PAW, and I'm going to make a call to my sync server, and I'm going to tell it I want to add a new record. And so if you watch closely, I'm going to play a little video here, because I don't do live demos. They always fail. And so I'm going to move the cursor over there, and I'm going to click, and then watch it add. And the UI updates as fast as my record got added, right? So that sync server knew that this app was attached to it, picked up that change, and updated the UI almost instantaneously. So let's talk about what just happened there. On the left side, we essentially added a record, and my representation's a little too simple here, but we added a record through the sync server to the server, okay? So we added some data in there through a service. The sync server said, hey, do I have anybody that wants to know about this change? And the answer was yes. I had an app sitting there that was like talking to the server, the sync server, and saying, hey, give me data when you have it. And it sent that data to the mobile device. And then the mobile device picked it up and changed the UI. So all right, now let's take a look at this in a little bit more, a more real-life example. So I've got 2 copies of the app running at the same time, and we're going to add and delete data on both sides and watch it keep in sync. So as you can see, I'm adding on one side, and it's adding and keeping this one in sync, and then I switch to the other device and add some records and delete some records, and it keeps sync on the other device. And that's all handled by the sync server. I didn't write any code to do that. So that, in my opinion, is pretty cool to have that sort of capability that you don't have to implement, right? So how do we do that? The first part, so we're going to go through all these different pieces here to make an app that does this. So we're just going to talk through all the code that makes this app work. So the first piece up there is like, how do we implement our model objects? Then we're going to talk about a data controller. And then we'll talk about fetching the data for the display, handling the refresh on change. So when you get your data changes, how do we deal with that? And then how do we add and delete data? All right, so the model objects are super, super simple. In this example, I just created structs. And the key there is to make them codable. So if you're familiar with Swift Codable protocol, we can take JSON with the same field names or same attribute names, and Swift Codable can just create these objects for us, given a set of JSON that has these values. If the JSON doesn't match what your values are, you can make some updates there and do your field names and all that kind of stuff, and it's really, really simple boilerplate code. So in my experience, this is a whole lot easier than setting up a core data object model and doing all that kind of stuff. All right, so that code's super simple. Now the data controller, we have 2 pieces that we need to do. The first one is we need a reference to our local database, right? And so that's just in a do-catch method. We just need to try setting up this database, and if it can't do it, like if it can't access the file system or whatever, it'll give you an error, and then you're completely hosed. Same as core data. If you can't set up your core data local storage, you're hosed then too. But in this case, yeah, we just need 1 line of code there to set up our database. Easy. And the next piece is a little bit more complex, and this is where we set up the syncing for our database. So there's a couple of pieces here to highlight. The first one is we get a reference to our database that we just created. Then we need an endpoint so that we know where our replicator is. So this is where our sync server is, okay? And then we're going to tell it a few pieces of configuration on how we want to do our sync. And the first piece here is how do we want to sync? In this case, I've got push and pull. So that means I can pull data down and send it up both directions. There are some cases where you might not want to do it that way. You might want to do a one-time pull, a one-time push, or separate your pulls and your push for whatever reasons make sense in your app. But for this example, we're just using the push and pull at the same time. And you can actually have multiple replicators if you want, and if that makes sense. And we'll talk about that in a minute. And then this next piece here is continuous. So that's if the app is sitting in your hand, it's open, and it'll continuously be listening for changes or sending changes if you create them. You can make that not continuous and just do a one-time check, and then come back and do it again at another time. So there might be valid reasons for you to do that in your app, and in this example, we just made it continuous to see the changes happening in real time. All right, and then you might set up some authentication, and then you might set up some change listeners. And in this example, I didn't do this because I'm really just updating the UI, but you might want to have some more complex logic. For example, if you're trying to handle some dependencies, and we'll talk about that in a minute, if you might want to have multiple replicators, you might want to do a one-time replication and then listen for when it's done and then kick off another replication, right? But a little bit out of the scope of this. All right, so now that we've got our data controller all set up, let's get some data. When the app runs and does all that setup, now the data syncs and you've got it. So you can query against it just like you're offline, and then when things change, you'll be able to handle that, okay? So here, this has got just a little bit of code that describes, how we're going to get this stuff for the display. So the first thing I've got there is, it says let document type equal green bar. This is just a Couchbase convention where you have an attribute in each document called type, and then that can identify your entity or whatever sort of data object you want to call it, right? And so in this case, I've got the green bars, the blue bars, and the red bars that are just separate different things, right? So I'm going to create an empty array of my fetched green bars. I'm going to grab a reference to my database, and then I'm going to create a query. And in Couchbase, their goal was to make their query syntax look a whole lot like SQL. So if you're comfortable with SQL, you can write a Couchbase query. Really simple. And in this case, I'm going to say, give me all from my database where my type is the green bar. And that's all I need. And then I can add more complex stuff, like I can have a where condition in there with, number of orders is greater than 5, or stuff that happened on Tuesday, or the sky is blue, any of that kind of stuff. Then I'm going to add a listener. And so this is how I handle the case where stuff changes. If I add a listener to this query and it stays active, right? So it's in my view controller, I've got a reference to it. This listener will get called anytime the mobile database says, hey, whatever answer you have in that query is now different. What do you like to do with it? And then you can create a handler that we'll look at in just a second to do something with that changed data. All right, and then the last piece here is you just execute, and this is pretty ugly code, but I wouldn't do this in production, but I ran my execution and then I'm doing my ingestion. So it gives me Couchbase objects back, which I could use, but I'd rather have my nice custom model objects, right, that I made in my structs. So I'm just doing an ingestion from those. I take the JSON that I get back from my Couchbase object, and I put them in my model object using Swift Codable. All right, so now we've got our data for the display. How do we handle the refresh on change? Well, this I did a really naive implementation, so it's super simple. It's really just, I grab the results of that, so that's my array, right? And then I say, hey, reload my section for green. That was it. You could get a lot more sophisticated with that and like animate it in and all that kind of stuff, but that's all you need to do is just refresh. All right, so now we've shown how we can get stuff. We've set up our database, We've pulled some data down. We've shown it in the UI. We're handling changes when they come in. Now, how do we handle the user-generated changes? To add a record, it's pretty simple. You just grab a reference to your database. You create a mutable document in Couchbase, and then you give it an ID. So in this case, I'm just generating an ID. There might be some rules that you prefer to say what your ID is, or you can have it randomly generated, either way. But in any case, any new document in Couchbase just needs an ID, a unique identifier. Then we encode that into JSON, and we drop it in the document, and we save it. And that's it. It's pretty simple. Deleting data, even easier. You just grab a reference to the database. You try to find the document in the database, given the ID that you've got. And if it's there, then you just tell the database to delete it. Really simple. So you remember the slide back before when we had all the code that was related to the API approach, and it was kind of understated? That's all the code we have for this. And since we can make a lot of that generic, it doesn't get bigger when you add stuff. So this is really, really simple, easy to grok. You know, once you're used to the approach, it's not a lot of code. So this, to me, was a really big benefit of looking at this approach. All right, so we've talked about all that stuff. Let's talk about some of the advantages of using a database like this. So one of the big advantages that I think is the significant simplification of all that syncing code, right? Like you saw the API approach, there's just a lot of stuff that you have to deal with. And here, you just need to set up a DB, set up a syncing call, and there's really no API calls needed unless you need to auth first before you talk to your sync server, right? So you can do all this with no network calls at all if you don't need to do an authorization first. Dependencies are a lot easier to handle, right? You can use nested objects, so your JSON can be sort of arbitrarily complex, and then all that can be ingested by Swift Codable, right? So you can do some fairly complex things very, very easily using an approach like this. And then this one, for anybody that's been bitten by core data and threading, these objects are thread safe. So if you create structs, or you just use the Couchbase objects directly, they're all thread safe. So you can fetch these in the background, pass them to the main thread or the main queue, and use them there, and you're not going to have any issues. So that, in my opinion, is also a very big benefit. All right, some more advantages here are, and I just sort of talked about the significant simplification of like model and ingestion code, right? Like that stuff just gets a lot easier to do. You don't have to worry about a lot of the stuff that core data needs. You don't need to create mode-generated, managed object subclasses. Your models can be classes or structs depending on what works for you. So you can set those up and you can make those, really, really simple to code. And then kind of the last piece here is on the API side is really a simplification of services, right? Your API calls can be a whole lot less complex. They need to handle a lot fewer situations on the server side, because really all you need to do are set up services that populate the Couchbase data the way you want it, or respond to changes in the Couchbase data and hand them off to your legacy data, if you even need to. If Couchbase is your system of truth or your system of record, you're done, right? So it can really simplify a lot of stuff. Now, there are some disadvantages to going this way, and I'll talk to you about a few of those as well. The first one is, really just a lack of familiarity. Like, when we first started doing this, we sort of didn't know a lot of stuff about this, right? And so it took a little bit of learning to get used to it and all that kind of stuff. But then we ran into some issues, right? Where, I showed the example of the architecture where you've got some services from the legacy data and it populates our Couchbase server. Well, we didn't realize that the client refreshed the staging database entirely every so often on a schedule, but didn't really tell us when it was going to happen. And so our entire data set got refreshed in the middle of a test and just blew everything up and ended up being a little bit painful there. So that kind of stuff can be a big deal, is you don't want that sort of thing happening, right? Like you want to be really careful. You need to change the way you think about those sorts of things. Because with an API, that wouldn't have been a big deal, right? we would have just said, oh, it's going to be down for a few minutes while the refresh completes. But this really broke stuff. It chewed up our sync server. It caused all kinds of problems. The next piece there is that architecture requires different thinking about really typical use cases. So for example, let's say I'm creating some user-created data. I'm filling out a form and hitting send, and my API call saves, and I do some validations on the server side. Now, what would typically happen is if I add the record correctly, great. It sends me a response and gives me a copy of the object I just created. If it doesn't work, it might send me back some error messages, right? Well, how do I do that now, right? So what we decided with some stuff like that is we would have another object in Couchbase sort of represent that transaction, right? And tell us either error messages or success or fail. And that might not be the way that works best for your cases, but it worked for us. So you have to rethink how you approach some of this stuff, because it will definitely not be the same as if you're using an API approach. Another piece here is that you can't control the priority of syncing. So let's say, for example, you've got 5 different entities, but you always want to sync one entity first before you sync the other stuff, right? Because you want to display that first, and you don't want to wait on the other stuff syncing before you display the first entity. If you use an all or nothing replicator that just syncs, you can't do that, right? So you can't control that priority. And that's where I was saying previously, if you can have more than one replicator, so you could set up a channel, for example, have one replicator for your high priority entity that you want to sync, and then set up another replicator that kicks off later for all the other stuff that you want to sync. So that's a little bit more complex, but it's still a whole lot easier than trying to sequence a whole bunch of different API calls and then try to handle the failure states and all that kind of stuff, and make sure that things happen in the right sequence. Lastly here, there's not really an NS fetch results controller type code for this. So if you want to do the sort of individual indexed updates to a table view or to a collection view, you kind of have to write your own stuff to do that based on this. But it looks like this week with some of the new announcements that might be a lot easier. And I'm like watching this stuff and going, geez, I already need to update this presentation. So yeah, all right. So what are the best use cases for this? One of the things that we found is when you have kind of a whole lot of slowly changing, the master data kind of stuff, and this is like for an enterprise app, if you can imagine, like regions or offices or stuff like that. So these are the things that are all out there. They get updated occasionally, but you need to have the data and you don't want to like load it every time, right? Use something like this so it's super, super simple to set up, keep it in sync, just do a replication every day. And you can keep a lot of this kind of stuff in sync. That's a really good use case for this. Makes it really, really easy to implement. User-created data is also a very good use case for this. So it's a really good way, especially if you have dependencies in your user-created data. Like if the Instagram example, right? If you want to create a post, have an image attached to it, and you want to let your user comment on it and like their own post, all while it's offline. Really easy to do this way, really hard to do that if you do it the other way. The last piece here is, though, that it's not really awesome for large amounts of data. So in this app that I built previously, when we started looking at it, we were like, oh, our initial records are going to be pretty small, 15, 20, 40 attributes, not a lot of data. And everybody would probably have 10 or 15 of them, right? So piece of cake. Well, reality intervened, and some of those records got to be, 15 kilobytes, 1.5 megabytes, hundreds of attributes, and people had like thousands of them. So that ended up not being as fast to sync using that. So we had to break them into like list items that were nice and small, and then sync the individual items later when they had them on their device. Yeah, so that's some of the best cases, not so great cases of using this approach. Questions? Can I answer any questions? She's going to come around with the microphone here. Yeah.
Just trying to ask one question about the truth.
Oh.
And that, how do you protect that? Because when that database gets hacked, the truth gets hacked.
true. How do you protect any database? A question in the back?
Yeah, thank you for the talk.
Oh, yeah.
I really like offline first approach. And the only thing I use Real, and a little bit of Real platform.
Yeah.
But we have like our tech is Ruby and PostgreSQL.
Mm-hmm.
So in order to do offline first, we need also backend effort. So what's the minimum effort from backend side to create offline first like on mobile from Real or Couchbase or other like vendors?
Well, it depends on like if your existing architecture, if you said it's like Ruby and Postgres, right? If you want to move away from Postgres and make, or if it makes sense to make something like Realm or Couchbase your system of record, and then you can still write services on top of that and use that as your database, then it's pretty straightforward to make that offline first capable, right? Because you can set up channels to segregate your data for the mobile users, and then they can just sync from that. If that's not feasible, then you can still write services, and instead of having your API call the services that do Postgres queries and return data, you can write services to write the records that the mobile expects to Couchbase or Realm, and then have the mobile sync with that. So that's two different ways you can approach it. Does that help?
So yeah, Real is also promoting that you have some code examples, but
Yeah.
It's also like backend guys can do it.
That's right, yeah. Yeah, and I didn't show any of that, so yeah.
Yeah, so I mean,
Yeah.
Is there like less effort on backend? So
I think there is because, you know, for example, the mobile users might have different queries that are a little more specific, right? And the queries might be more difficult, if that makes sense. So like longer queries, they might, you know, require more indexes, all that kind of stuff. Whereas if you write when things change to your source data, and then you write those changes as they happen, you're just writing like a full record or whatever, right? And it's a little bit simpler, I think, to just populate that data when it happens, right? So that's one theory on it, but you know, your mileage may vary in real life, I would say. Yeah. Yeah.
thank you.
Yep. Yeah, another question over here?
Can you make your slides available?
Sure, yeah, I'll make that done. I will post it on Twitter, okay? Yeah. More questions? Yeah, you want to bring the mic up?
Is it possible with migration approach for changes in database like Realm?
I'm not familiar with how Realm does the migration. I haven't looked at it recently, so I don't know. Yeah, yeah. I do know that the way I treat migrations in Couchbase is very much like an API. So I will do like non-breaking changes. So you'll, instead of changing the name of something, you add a new attribute, and then deprecate. Don't populate the old attribute or don't change it until you know. You can prove from your analytics that the old version's gone, right? And then you can delete it. I mean, it's not terrible to leave it there forever, right? But you can always just, you know, leave it or delete it when it's done, if that makes sense. Yep. Any other questions? Oh, yeah. One over there.
You said that there was
You had mentioned that there would be a max number of transactions that you say this is the cap, you don't go beyond that. What number would that be?
It depends on your server setup and, you know, like how many sync servers you've got. Couchbase, you know, they like to build themselves as being very horizontally scalable. So you can set up a lot of different servers and sync servers and make it very horizontally scalable. So you can do a lot of transactions. But what I would say is a best practice would be to keep your records or your documents small, or as small as you reasonably can. And for anything that's going to do a lot of syncing, keep those pretty small. So tens of attributes, less than hundreds of attributes is a good idea. And then for larger records, if you do need to do those, you can just put those in a channel or something like that and say, hey, I need to get that document. And then you can pull it and sync it directly.
One other question.
Yeah.
In terms of turning specific bits of data into encrypted. Can you do that?
Yeah, you can put whatever you want in the JSON. So it could be all encrypted. Yeah, I don't know if they support currently like encrypting all the JSON at once. Yeah, you might be able to do that, or you might just be able to populate your JSON and say, encrypted record, here's the encryption, and then you decrypt it and ingest it. That would work as well, I would think. So yeah. Cool, I got time for one more question if there is one, and then I need to relinquish the stand here. Any more? All right, well, thank you all very much. Please stick around for James Dempsey next. Thanks. That's Twitter. And yeah, thank you.